so yeah, I'm Matt Johansen. I run the Threat Research Center at White Hat Security. And you just saw my talk next door. The lovely speaker wranglers of WASCON, including James Wickett, booked me twice in a row for whatever reason. I also did not make this bio slide, so the Beard of Destiny is not my addition, but apparently it's fitting. I don't know. Do you have an explanation?
Who would deny Beard of Destiny's status?
That's true. Okay.
Can anybody compete with that? No.
I don't know.
Okay.
So, yeah, that's true. That's true. So Gauntlet cheerleader, we're going to mention Gauntlet in this talk, and he runs Gauntlet. And I would like to say I'm a contributor, but I don't write Ruby, so I'm a cheerleader. And yeah, I've done this speaking thing a few times. Yeah.
Yeah, cool. Yep, and I'm James, and I work on Gauntlet. And right. You like my photo? Yeah. No, I have no beard to compete, so I was like, what else can I do here?
I think he's looking at you guys.
You guys watch it over there. And I work at Signal Sciences, and we are a startup working on making AppSec effective and practical AppSec approaches, implementing them. I said that completely wrong, but you got it. Yeah, I should just read the slide. We're making AppSec effective and practical. So it sounds good, right? And very mysterious. And if you want to find out more, we have our website, and you can just click in there and give us your email address, and you will be mysteriously contacted about that. So, but we want to find out real quick, like, where are people in the audience coming from? Like, what do you do? Are you on the cloud? Are you using kind of bare metal? Metal?
Everything.
Cloud? Hybrid, okay. Who's like all cloud? Yes. All right. Now I'm scared, actually. Okay, and who's all metal? Okay, and so pretty much everybody else is like a good mix, right? It's like we had some stuff, and then we're like, oh, this cloud thing sounds great. Now, do people mention the word DevOps in your organization? Yep. Okay, about half. Do people mention Agile? Do people talk? I'm not saying you actually have to be Agile or DevOps. That's a whole bag of worms, right? That we don't want to open. Yeah, I don't know yet. We were up too late last night. Yeah, bowling, and yeah. Okay, and okay. What about how do you guys get how do you get code to production? Is that like a 1 week process, daily, monthly? Monthly or more, okay. Weekly or so, okay. Daily, lots of times a day, okay. Great.
All cloud, all daily.
That's right. Conda's keeping it real back there. All right, great. And then, okay, how do you do security testing? Do you do security testing kind of like after it's been deployed, or do you do it kind of somewhere in the pipeline or in the mix? So if you're early on, raise your hand, like if you're kind of considered early in the pipeline, okay? If you do it sort of like, it's been out there, it's like, getting crufty or whatever, but you're starting to be like, okay? No, hey, there's no shame about that, feel free to. And then, what if you kind of mix, right? Maybe you do some parts of your apps you do really well, and some parts like we don't touch that one because we know, and then maybe it's just like we just only do it a little bit for like PCI or compliance or whatever. So I see. Yeah. Okay. So I mean, it's kind of what we expect, kind of a mix here. And so some of the things we're going to be talking about are the way we see the world shifting and sort of some principles that we're going to look at for how you do a modern security team or modern security approach, and we'll also be talking about what are some good practices. Matt has a ton of experience in his life and his job about how can we help fix some of these things, and he's going to give you some real practical things that I think will be helpful, and even as security folks, or if you've been exposed to AppSec stuff that still should resonate with you, and you should kind of click. And then we're going to, at the end of the talk, we'll do sort of like what does it look like to have a build pipeline with some of that stuff integrated. But I thought it would be good to start out with like, okay, what does the world look like today? And I like this awesome definition. That's how it's pronounced, awesome. And actually, I want to add a P to it because this is like a definition for this is actually a definition about the cloud. And so then you could call it possum, and the P still deciding what it would be, maybe public. I don't know, but something like that. But anyways, we'll stick with awesome. But when you look at this list, it really should stick with you, and you should think, oh yeah, this is really kind of where the world is heading. I see part of it in my organization. I see part of it out there, but people want to get stuff that's on demand. You want stuff that's scalable, self-service, and measured, right? And this is sort of a definition that's been proposed as like, this is what cloud really is. We don't have to like call the little VMware cluster you have like hidden in a data center cloud. Like I know that your boss maybe wants to call that cloud, but like when we're thinking about cloud in a real practical sense, from all the way from SaaS to infrastructure as a service, this is what we're talking about, what we're thinking of, and it makes sense because in the consumer world, it's like, oh, I get my my Gmail application, and it's like, wow, like I get email. Sorry, Robert. I get email a lot easier than I do at work, right? It's like it takes a week to provision and all that sort of stuff. And in the old enterprise approach, and people are starting to see like commercial and consumer tech is better than enterprise tech. And so, and I saw this. This stuck with me about 4 years ago. I went to National Instruments to do a cloud startup there. Inside, we're basically taking some tech and cloud enabling it. And in previous gigs, whenever I would like buy or acquire or make decisions, I would like, I had like a whole grid, right? I was like, how does it perform? What are the feature sets? How much, how does Gartner think about it, right? That really mattered to me. What does the trial period look like? And how are we going to pay for this thing? And, what's the support costs and all that? Whenever we switched to cloud, it was like really simple. Like, do you have an API? Can I integrate you with my other stuff? Do I have to pay you yearly big contracts, or can I just give you a credit card? And then it's like, oh yeah, and do you work, somewhat okay? That was what we started doing, and it really kind of assessed to me like we need to be about the business of playing nice with others, and like so inside of security, like if we can do that inside of the organization and fit into the new way that people are doing things in the awesome world, that is really important. This is a long-standing business thing that people have heard of, and it's people are more important, and so we'll just skip through that and say, yeah, influence the people in your organization. Okay, let's talk about DevOps. Like how does security play inside of a DevOps organization? I really like the CAMS piece, sometimes called clams, and that's also debated. You can see how people love this stuff. But this is John Willis and Damon Edwards. They run the DevOps podcast, and it's a culture, lean, automation, measurement, and sharing, and high emphasis on culture. Like that's one of the big pushes in the DevOps movement. For many years, they were just like, DevOps is culture. Like, don't talk about anything else. Like, don't talk about your chefs and your puppets and Ansibles or whatever. Like, we want to talk about culture, and like it's a complete correction and a change of course correction here. So, a short story on this. At my house, we have a moon culture. My daughter is 2.5 years old, and she knows the difference between a crescent moon, a full moon, and a half moon. We go on walks and like it's like it's kind of dusk, and there's the moon. She's like, the moon, and I'm like, yeah. It's like she's really excited about it. We start telling stories about the moon. So I have a little story I tell her, and it's like, we're gonna build a rocket ship, and then you're gonna fly up to the moon. And it was really cute. One day she was like she saw the moon. She says, I want to go to there, And I was like, it's like that warmed my heart, right? As a dad, I was like, well, math and science very important, But we started orienting around the moon, and then I started realizing how effective this was, because one night I was taking out the trash, and I look up. I'm like, I wonder where the moon is. Like, what do I care where the moon is, right? But then I could tell Lydia where it is, and we could have a moment. I downloaded an app to tell me the phases of the moon, and so I could be like, yes, honey, it's a waxing gibbous moon tonight, and stuff like that, right? And so the point of that is, besides just being kind of silly, but is the things that we value, in our culture, dictates kind of the stuff that we value. And so your tooling and your other things that you put around your culture that is what really sticks in an organization. So, there you go. And continuous delivery, I think this is the last point here. There was a book released several years back, and you can sort of trace back a lot of this to the Flickr days, whenever they said, we deploy to production 10 times a day, and everybody's like, what, But then it started really thinking about, what does that mean to deploy? What does that mean to deliver? How do we actually, influence? How do we deliver to our customers? And so these are some sort of guiding principles. And then I think you could arrive at this conclusion that there are really two paths in the security industry, or like how we can influence and affect kind of the way things are going in the industry. And one, I think, is really important. That's what we're going to spend our time talking about, is the development and build pipeline. And so, in a world where code commits and tests and failing tests and all that stuff are currency, security people can actually play in that really well. And then I also believe operational runtime state and monitoring is also the other place. So what's actually happening while it's happening. We're not going to talk about that one for this. We're just going to really focus in on the dev and build pipeline. So Matt is going to talk to us and kind of tell us the stuff he sees and how it's going in the industry.
Apparently I am. Okay, so so detect and fix and development is kind of the point here, right? Is oh no, mic, this isn't working. Huh? Okay, I'm just gonna take it off. We're gonna trade when we kind of asked earlier where you do your security testing, this is kind of where this falls in, right? Okay, so do you do your security testing as you're writing code? Are you doing static code analysis? Are you doing security testing when you put your code in some sort of QA environment and you're doing dynamic analysis on that living QA environment? Or are you just kind of, let's do the scan at the end when it's all in production already and let's scan it, right? This is really important, especially when we go back to the other question that we asked, is how often do you deploy to production, right? So now, if you deploy to production a month or greater, or even weekly, or bi-weekly, and you don't do any security testing until production, now all of a sudden you know about a bug in production that you cannot fix for days, weeks, potentially months if you can get the developer time. So this kind of stuff gets pretty scary, right? So some of the stuff we've been preaching for years is, okay, move that security testing back, right? Move it back earlier and earlier in the process, which is still really smart. But people like Flickr and Etsy kind of turned this on its head, and they said, hey, we push 10, 20, 30 times a day to production, and security people go, what the heck are you talking about, right? How do you review that code before it goes out? How do you do change control process? How do you know what's changing, and so that you know where to focus your security testing and all this kind of stuff? And I gave a talk at Black Hat this year, and we were just kind of a roundtable discussion at one point about this whole realm of what we're talking about. And one of the guys from Etsy was in the room, and he said, well, vulnerable code existed before we started pushing 30 times a day. Vulnerable code is a thing that existed when we only pushed once a month, right? We can now fix it in a couple hours. And then that kind of was like, oh, okay. Yeah, the room kind of was like, and they just started nodding, right? So this is kind of the theme that we're going to go on for the next couple slides. So we usually give this kind of presentation to more developer-focused people. How many people in the room are more developer than security? Cool. Okay, that's awesome. Okay, but you are at an application security conference, so I think a lot of this is going to be a review. I tried to pull out some of the super boring stuff for people that would actually be coming to an application security conference. But anyway, so try to make this interesting. So for those of you not familiar with White Hat, we put out a stats report every year. We publish it. We have 35,000 websites under contract. That's a really cool data pool of vulnerabilities. And this year, we always do a little spin on it every year. We did a customer survey to ask people their develop the same kind of questions we just asked you. We tried to correlate that to vulnerabilities. And this past year, we actually correlated the vulnerabilities by language, right? Just to put a new spin on the data and see what kind of came out, and maybe start some sort of religious war amongst developers, because we're just presenting data. These are just hard numbers that we have. We are not making any claims of one language being more secure than another, but this is just what we see, right? So this is what you're looking at here is vulnerability percentage by vulnerability class by language. So the percentage of sites that we have in each language that have at least one of these vulnerabilities. Does that make sense now? So you can kind of see the heat map coloring is, cross-site scripting is everywhere, right? We've known about this forever. And how long have we known about cross-site scripting, Robert? 2001. We've known about cross-site scripting. And in sites, I mean, I don't know how many Perl sites what we have, but 67% of them have at least one cross-site scripting bug. But if you tried to draw a line somewhere near all of those numbers, it's pretty easy to say half. Half of the sites that we test, period, have at least one cross-site scripting bug. Most of them, it's going to be a lot more than that, right? All the way down the gamut, information leakage, content spoofing. So vulnerable code is everywhere, right? This is just something, I'm not going to spend too much time on this, right? What is this? I didn't put this slide here. You're throwing curveballs at me from 10 minutes ago. Okay, so I ripped out a lot of the what is cross-site scripting. I hope that you guys, you're out at an application security conference. I hope you know what it is, at least in general terms, and why it's bad, right? But still, I find that how to fix cross-site scripting still kind of resonates with a lot of developers. I saw all your hands go up. That's really good, right? So something we've been preaching for quite a while is input sanitization, right? And that's great. That's phenomenal. Okay, it's not a terrible way to do it, right? There are better ways to do it because input sanitizations usually means blacklists, right? Usually means if you see this special character, don't allow it, or something like that, right? If you see this string that kind of looks like cross-site scripting, block it, right? This is the worst cat and mouse game ever. We see it all the time where certain clients of ours just insist on doing blacklists, and all it is we just, break it again and break it again and break, okay, we're gonna encode this way, we're gonna encode that way. When you implement a blacklist, you have to be smarter than the attacker all the time as the defender, right? You have to be on top of every new technique that comes out, every new browser version. You need to see how it handles input to update your blacklist. That's a gigantic task, right? I don't want it. Whitelists are way better, right? Hey, here's this input. It only ever should have letters or numbers, okay? Just don't allow anything else, period, done, right? If you want to allow special characters, you still should disallow a significant amount of them, right? The whitelist is just way better, of a global strategy on XSS than blacklisting. But even better is output encoding, right? So how many of you are familiar with output encoding? Cool, I'm gonna skip right past it, right? This becomes this, and we're all golden. SQL injection. We kind of left some of the basic stuff in here because it's just kind of cool to remind ourselves of how prevalent it still is. Robert, how long have we known about SQL injection? 98? Christmas Day, 1998. Still everywhere, still really bad. You all are kind of familiar with this. I stole Jim Manico's password. If any of you are familiar with Jim Manico's presentation, he always gives out his password. I don't know why, right? It's silly. But just really basic, what SQL injection looks like. This is kind of like our first interview question if you're coming to try to work at White Hat. It's like, here's select star from users, where username is Matt, password is Fluffy Bunny, and you can just kind of edit the SQL query from there, right? The SQL query becomes or 1 = 1, and you're in. And of course, we have to do the obligatory XKCD comic when we talk about SQL injection of little Bobby tables. This resonates really well with people that haven't seen it before, but I'm assuming most of you have. Okay, so how do I fix it? Parameterized queries. This is king here. There's really no argument about it. It's not, blacklisting, whitelisting. I mean, you could input sanitize. Like, there are people that try to fix SQL injection by not allowing SQL-type queries in the input, which is okay, but again, you're fighting the battle of what is SQL injection and maintaining that, when this is way easier. Parameterized queries. For those of you who write PHP, this is what a parameterized query looks like in PHP. So this looks familiar to some people. Cool. Instead of just taking the user input and throwing it directly into a SQL query, you're parameterizing it first so that no matter what that input is, it's not going to affect the SQL query, period. That's the gist of it. This is the syntax for PHP and Java, right? The only difference here is, Java uses these question mark placeholders and PHP does the little colon trick. Cool, look familiar, makes sense to everyone. Parameterized queries, not too new. Okay, cool. So cross-site request forgery, also absolutely everywhere. We see it constantly. We've known about it for a very long time. We know how to fix it. It's actually really easy to fix. This happens, I think this happens twice a year. I feel like this same exact headline shows up every 6 months, usually in Brazil for some reason. And I think this was Brazil, I can't remember, but the routers are just awful at protecting and stuff. It's like, oh, well, it's not available on the internet, so whatever, right? We don't need to worry about cross-site scripting and CSRF. And every year, we find a way to CSRF, oh, we changed your router password, we flashed the firmware, and we're just perma-owning your entire network, right? And this happens all the time. For those of you who don't know what that attack looks like, for the router attack, you visit some malicious website. The JavaScript on that website can force your browser to make a request to your router, right? Since people on the internet can't make a request to your router, but you can. Force your browser to make a request to that router and do all sorts of nasty stuff, right? Change the name servers, you can flash the firmware. I think every year at Black Hat, some new thing that someone did to a router via CSRF is a talk, right? How do you fix it? Anyone? What's the easiest way to fix CSRF? Not? Okay, I knew you were all going to say tokens. Well, okay, you're right, it's tokens, but there is an easier fix to the CSRF that most people probably don't even realize is a fix to CSRF in one particular situation of CSRF, and it's this. Right, so your change password page, right? If it just asks you for your password, if I force your browser to just make that request, I just changed your password, right? You don't need to tokenize this, you just ask for the old password. This is actually a CSRF protection, right? Little nugget of truth, right? Okay, tokens, yeah, you all said tokens. Really super easy, everyone knows what this is. If you watched my last talk, I showed you a few different ways that people are stealing CSRF tokens, and this is why they're stealing them. For those of you not familiar, a CSRF token is you add some random, giant, unguessable string that is not known to the attacker so that they cannot force a legitimate request from your browser to actually do some CSRF. Make sense? Again, just a reminder, this stuff, so these things that I just showed you is just unbelievably everywhere. And this is kind of, we're going to get back into developer land here. It gets fixed really slowly, right? So this is, what this chart is average days open per vulnerability, per language. Ruby is hard. We don't have a giant sample size for Ruby, and so that's why that kind of goes away. So Ruby's a cool hip startup language, and they usually can't afford high-end web scanning. And metrics, right? So Ruby's kind of our outlier that yeah, we put it on there because we do have some with some cross-site scripting and stuff, but the rest of them we just didn't find enough vulns to show that. Okay, so HTTP response splitting in ASP is actually one of those outliers that's like vuln by default, incredibly hard to fix in ASP Classic. It's kind of silly, right? But on average here, you see triple digits all across the board that these vulns are open for. Just another cool data visualization of how long these vulns are open per language. I'm going over my time, as usual. If ever. So this is just open. So that was time to fix if they ever got fixed. This is just remediation percentage, right? So this is the percentage of times it's ever even remediated, period. So blue is bad, I think. Oh, no, blue is good. So 100% of the time, some of these, right, in certain languages, and then red is bad. So you're still seeing, from the time that a site came under contract with us till present day, they only fixed 79% of the cross-site scripting that we told them about, type of thing, right, if that starts to make sense, per language. Cool. So these vulns are everywhere, they're always, step 10 slide, I'm going to blow past that at OWASP conference. There you go.
Cool. All right, so now we talked about what does it look like to have a build pipeline, and how do we put all that together? Hey, does anybody have laptops and they want to actually set up a build pipeline? You don't have to come to the front or anything, but I was wondering, we have some.
We usually do this as a workshop.
Yeah, we usually do it as a workshop. We could do it kind of workshop.
Or we do it as a demo. It doesn't matter.
Do a little bit of both. People are like, I don't bring my laptop to here. I don't trust my fellow attendees. All right, well, it's all right. We'll do a little bit of a demo, but the whole idea is that what you could do if you wanted to, and maybe I'll make it available, or I'll kind of help you if you're following along. But you can we have a repo in GitHub. You can fork the repo. You can set up the Travis build for it, and within just a few minutes, you'll have your own build pipeline with a running website. We used Matt Konda's triage application. It's a Ruby on Rails application that we stood up for it. and then we run some Gauntlet attacks against it, running different type of stuff. And we'll actually go through that. I'll click through it, and you can, if you like want to do it later, you can. But I think it's a reason why we're going through this, and we want to talk through it, is because a lot of times in organizations, well, here, how about this? Like, who uses Jenkins? Yeah. Travis, anybody use Travis? Familiar with Travis? Okay. So Travis is cool. It's all the stuff that you don't like about Jenkins isn't there. Well, they're actually working on adding those pieces back into Travis, unfortunately. But it's a real simple version of Jenkins. Yeah, don't tell the Travis guys I said that. We'll delete that from the video. Anyways, but before we get into that, like let's talk about like what is going to be the test runner, and our test runner is going to be Gauntlet. Gauntlet, if
who's heard of Gauntlet?
Yeah, people familiar with Gauntlet?
Cool.
Okay. All right. So yeah, we'll do a little bit of how it works, and then we'll get through it. And you can actually see the code and how it all pieces together. I think that's probably the most helpful part. Okay. So it's built on top of Cucumber, really just as an extension on top of Cucumber. The important parts about Gauntlet is it comes with pre-canned steps. So one big knock against Cucumber is that you can like write one step like 20 different ways, and you can have a lot of overlap. Right now, Gauntlet doesn't let you bring your own steps. You actually have to use the pre-canned steps that they have, or that we have in it. And some people like that, some people don't. But it helps you avoid that kind of nightmare Cucumber scenario where you have like, if you've had to deal with it, you've seen that before. And Gauntlet doesn't install any tools. It's not a package manager. Doesn't do anything like that. So you have to already have that stuff built up around it. It tries to be a good citizen of the continuous integration and continuous deployment pipeline. So with clean exit statuses, and make sure that it handles all that properly. And it's an open source license. So what does a Gauntlet attack look like? This is how it's structured. So the idea is given, when, then. If you can say those in that order, you are now an expert in Gherkin. Which is the language that Cucumber uses for this, but it's the same thing for Gauntlet. But there is the idea of a feature, or like kind of the big main story that you're testing, and then individual scenarios. Now that stuff that's run up at the top where it says background, that gets run each time before each scenario. So each scenario kind of operates in its own independent environment, and every time it's going to make sure that like nmap is still installed and everything's all set up for it. And you can do other stuff, and there's some other tests that you'll see, like this is a real basic one, but you would do things like, here's my login page, set some environment variables, anything that you're wanting to stand up and make fresh every time, it would do that. And it's also important to note, like the test there in the middle won't affect the test at the bottom. So whenever it says the output should not contain those lines where it says the then, those don't mix and match, right? So every time it runs, it gets a clean set of output, and that's what you're parsing there. So this one is running just a port assertion. So it's like on example.com. I want to make sure that when I run nmap that port 80 is open. Later, I want to make sure that port 25 is not there and not listed, right? So yeah, 443 is fine. I mean, you can test for anything, right? So do I have a typo on there? No. Oh, okay, yeah. So, yeah. But you look at this and you're like, all right, so let's make sure that all this is set up properly, and we'll see some other like Gauntlet attacks that pull through there. Here's some quick links. We'll have the deck up so you can click these and.
So I just want to take a step back and reiterate why this is really cool and really important, right? Because James has done this, so he knows that it's cool, right? So not too many of you have heard of Gauntlet before, but the reason we kind of go around talking about it is. Like that whole moving security testing early and earlier thing. Now you're not even putting security in the security person's hands and saying, okay, developer, like when you write your code, I'm going to run my static analysis tool on it, right? Which is currently kind of the earliest phase that we have. This is actually, you're speaking developer now, right? Hey, you already write QA tests, right? You already have to write your QA test, your unit test, your end-to-end tests. If you're doing any sort of continuous deployment or this pipeline, you're having these tests, right? So just going back to what James started way in the beginning, getting into the culture of, okay, besides when I click this button, it turns blue, right? When I click this button, it also doesn't, I can't force this button to be CSRF or something like that. If you start to think about these things in security terms and unit tests, and that's what Gauntlet really is doing, right? It's writing security unit tests with some help of some outside tools. This is even earlier, and now you're also speaking the developer's language. You're not all of a sudden being the security guy trying to butt heads with the developer to get, hey, hold on, we can't push this code to production. I didn't look at it yet. No, okay? Hey, we have some bar here. Our unit test went out. It is at least this secure, right? Because the unit test passed, the build passed, the code went out, right? I'm not saying stop testing in production because of this, right? Because that would assume that you're writing perfect unit tests. But I just wanted to take a step back and picture that.
Well, yeah, and that's a good point too. I think another aspect you see is like sometimes you fix a vulnerability or you put something out there, and then later like you make a typo or a change or something like that, and you have a regression, right? And now that thing is back. So you can help systemize some of the vulnerabilities and things that you've found through this process. And I think
that's another stat that we actually use in our stats report. The screenshots I was showing before is reopen rate. And like we see these vulns pop up. Okay, we had a vuln, right? And so the way that we work is every vuln gets a unique ID for the lifetime of that vuln period, so we can tell if it's that same exact vuln that comes back again. And we have a reopen rate. And we have some theories of why this kind of happens, but it still happens way more than you would expect it to happen, right? One theory, and kind of like this with the pipeline, is like, okay, you have this whole QA process where you put this code into QA, and then it does this, and change control, and yada yada, and it goes out to production, right? And then we find that the reopen rate is higher for the most severe vulns. Like the SQL injection has the highest reopen rate. I mean, like really, really bad stuff. And we think that's because it's like a hot patch. All of a sudden that goes out of the regular pipeline and out of the QA cycle. And we got to go, everyone's hair is on fire and we got to get this fixed into production yesterday. But no one implements it in QA, and then the next time the QA goes out, the vuln's back. Right? And so, yeah, like you said, this kind of standardizes it to make sure, okay, we fix that vuln, make sure to write a unit test with Gauntlet so that, that vuln doesn't come back ever again, period, right?
Yeah, cool. Well, if you're interested in Gauntlet, if you, through the life of the conference, if you send an email to book@gauntlet.org, you can have a free Gauntlet book. All right. Let's take a look. This is what we're going to go through. There is a repo called there's an organization on GitHub called Secure Pipeline, and then there's a Rails Travis example. So if you have a web browser and you want to go over to github.com/secure-pipeline, you should see the Rails Travis example. Now, Travis, we'll get into. I'll actually pull it up and we'll look at like how it runs and how all that sort of stuff works. But Travis operates on this file .travis.yaml. And you can see there's some real simple, like, okay, it's Ruby up top, and it says like a 2.0. And before the install, I'm going to do a bunch of stuff. So it does like install nmap, SSLIs, SQL map is up there. Arachne is inside of, we have it packaged as a submodule, so it's inside of there. So there's all this like before stuff, right? And like, so your build is sort of just setting up everything, getting everything ready. And then there is the script. We're actually running before. Because I wanted to really focus on the actual tests, you wouldn't probably do it exactly this way for an app that you're building, but you maybe would. But the before script is we set up some tokens, we set up the Rails, we do a database setup, and then we start the Rails server. And so everything's fired up. And so at that point, this is the real execution of the tests. And there are 5 statements down here, and they're broken up in different rake tasks. And rake is just a Ruby kind of like harness that we're just using. So it does nothing more. It's super easy to read, but it helps you kind of bundle everything up into different statements. And you can see there's different ones down here. One's called network attack, SSL attack, Crosssite scripting, information leakage, and SQL injection. So we'll take a look at a couple of those. This clarifies a little bit on some of this, but you see the setup pieces. And there's we'll look at these two right here, the information leakage one. I don't think we'll look at SQL injection, but just probably that one. So for this one, if you notice, there's 3 different attacks, and you can see there's Gauntlet on the left-hand side, and then it's kind of a path, but it says email leakage.attack, backdoors.attack, and derby.attack. So The email one is, sometimes people will crawl your website and grab all the emails of users or that they know of, and they'll make a fuzz list off of that. And so you can say, well, anything that contains my domain name, like don't let that be out there, right? And I want to block that. Backdoors is like, has somebody put something in like some sort of PHP or some sort of executable backdoor in your system that's well known. It's not completely likely, but if it goes off, you really want to know that, right? It's like that's like one of those ones is like it will probably never go off until it does, and then you're like, oh crap. So here's what the email one looks like, and we're doing some of this, set up a profile, and so inside of Travis, that whole thing is starting up on Rails on port 3000. So we're looking at localhost port 3000. So this is all contained. Travis has its own build box that it sets up, does all the pre-configuration, and then now it says, I want to launch an Arachne attack, and I want to look at the module's emails. And then the output should not match whatever your domain is, right? And you could parse this in any sort of way. There's lots of like regex availability for you there. And that makes it real simple for you to look at. All right, and there's that piece. See, I got ahead of myself there. Here's the backdoors attack, and then this is the SQL injection attack. So this is showing, I think something that's really interesting about how we use Gauntlet and how we work with Gauntlet is like this right here. This is not speaking the language of developers, right? Why? Because this is really confusing, and this is like a SQL. This is a SQL map, mad science that like the security person knows. But you know what? Like what is speaking language of developers? Like this whole file, right? Because it's like I don't know what this is, but I've been told that like this is bad, this fails. Like now I know I got a problem, and it can be taken that way. So we're sort of like taking that knowledge that's been kind of hidden away in the information security, application security silo, and we're systemizing and making it available to everybody else in the organization. Okay, let's do a demo, and let's try some things here.
Did you sacrifice the demo for the demo guys, the goat this morning?
No, I'm like dependent on Wi-Fi. I'm like worst possible demos. I'm dependent on Wi-Fi. So,
You must have a video backup or something, right?
I have no video. All right, so this is our application. This is stood up just on our local. Oh. Let's see.
That's a great application.
Slide it over. Just grab it, slide it over for a second screen.
Yeah. Actually, let me mirror this display so I won't give myself a serious headache here.
And that works.
All right. Can you see this? Okay.
Your toolbar is good in the way. Your document.
Is that pretty good? Okay, cool. Thanks. All right. So so this is the application, and it's running just on my local machine. You can see there. It's pretty simple. This has cross-site scripting and other problems with it. But we're just kind of standing it up as an example. Like here's a Rails app we want to take a look at. If you go to this repo in GitHub, you can come down here and you can just say, I'd like to fork the repo. Notice we had 177 people fork it. It's pretty amazing. So we're pretty excited about that. So let's try to get to 200. But what you can do is, you can see right down here this little button. It says build passive. And let's click over there. Right. And so this is what the Travis output looks like. So it gives you a build number 57. It ran for about 6 minutes, and I was doing that yesterday. It has different pieces to the build that we talked about. So it has the whole setup piece. It does. It first checks out the repo, does the submodule updates, all those statements. These should look kind of familiar. If you just go through those, like that's what we said earlier. Like there's these. It actually labels it. If you see, it says before install, right, and then it like does all that. And and then there is the before script, which are those portions right there. And then it actually starts the script, right? It says, okay, here we go, and we start going through there. We're just going to read through a couple of them, and then we'll open up a couple of attacks. I think we've got a couple of minutes. So here is the here's that nmap attack, and it's running. So here's that nmap attack, and it's running there, and you can see it's looking for port 3000, and you can see at the bottom it says I found that, so I'm going to call that good. You'd probably want to say like these certain things not available. Here we're checking for Heartbleed, and we're checking for Heartbleed against Google, not against ourselves since I don't have the search set up. But that's another cool thing about Travis. It can actually make like outbound requests and has the ability to do that if you have some sort of requirement for that. And so we're here we're saying, okay, not vulnerable to Heartbleed. That's what it needs to say. And here's like the statement right there at this line right here, right? And it validates that. Okay, let's see some other ones that look interesting. Here's a cross-site scripting attack. So we're using Arachne as the engine underneath there to test that. And so we're like, well, let's look at the new password page. And one really important thing about some of these tests is like the security scanners, you could like turn Arachne on and like walk away for a day, right? And like depending on your site, like you could come back and it could be crashed, or it could be still running, or you're just not really sure. So we have some filters in here like saying, okay, only go to one page. Don't go throughout the entire site, because these things need to be fast. Like you can't just put a bunch of tests in there that like take forever to run. Let's see. Okay, we have 2 minutes. Maybe we could let's do this. So the rake file inside of the repo. So as you kind of look at through, you're like, well, here's the attacks, and let's pop open another one of the attacks to just take a look at it real quick. And so that was inside of test, and inside of attacks, and let's look at that. Let's look at the email one. So again, we're using that real simple Gherkin statement. We're saying, given I have my testing tool installed, when I launch this attack, then the output should match over here. And that makes it so it's real discernible of like what's actually going on. And we could actually change this. So, oops. And we'll say my domains. All right, and then when I do this, is going to fire a commit into GitHub, and this is going to kick off a new build. All right, and then this is the update to the email leakage, which we just pushed. It shows our commit number, and then click into it, and we'll let this run. The build status will populate as we go. We are using the Arachne scanner. So it's not that we're just, we haven't like hard-coded what cross-site scripting means. Like we're using the Arachne scanner. And then we're saying, hey, I want to like pull out, and you can do it with other type scanners, like that's totally possible. And then I want to look at just the cross-site scripting types of attacks that they offer. And I only want to look on certain pages, on the pages that I know that exist, right? Because a lot of these scanners, they end up trying to build like a crazy map, of your entire site, and that takes a lot of time, messes up your build completely. So what we're saying is like, go after the password page, go after this page, run all your cross-site scripting payloads. Like we're telling Arachne to run that. We're just saying don't go nuts with trying to find a bunch of other pages to identify. Yeah, this is kind of a minimum bar, right? It's like it is possible to have cross-site scripting that Arachne is not going to pick up, on one of those pages. But you might also have it, right? So this is like in the build pipeline. This is where you can be effective inside of security, right? This does not replace penetration testing. This does not replace good coding practices, all that stuff. So this is just that kind of helping set that minimum bar across your organization. It's funny, like the one that people really like a lot is the nmap one. Is like sometimes people spin up new services on their pieces that you're like, we didn't even know, right? Like Netflix uses Gauntlet, and PagerDuty uses it, but a lot of them they use like we're just trying to make sure people don't start up new random things that we don't know about. There's a Garmer plugin, and Garmer is one of the Mozilla projects. It's like, okay, how does Mozilla do development? And we want to make sure that it fits to our model, and we want to make sure that code doesn't go out that goes against our security policies. I know people that have taken Gauntlet, put Garmer with it, and Gauntlet has a little test that says is this a login page, right? And anytime it finds a login page, the security person says that's an error, right? Because it's they just want to know when new functionality for logging in to the application or an application in the organization pops up. At that point, then they're okay, we're going to engage that, do a real pen test on it, and then we'll go back to putting in actual tests for it. So it's kind of a watcher. It can be a lot of different things for it. So I know we're over time. Sorry about that. But
if you have any other questions, you can
we'll be
find either of us on Twitter, or we'll be here for the next 2 days. So, yeah.
Cool.
Thanks, guys.
Thanks. Yep.